Electricity cares about the structure of matter. Gravity doesn't. If it's got mass, gravity pulls on it, end of story. But to study electricity, we have to talk a little bit about the structure of matter. Now you probably know that ordinary matter is made out of positively charged nuclei with negatively charged electrons around them. And how those electrons behave is determined by what kind of material it is. See, a superconductor will let electrons flow through with perfect ease. You try to send electrons through and they will just zip right through, no problem, no energy loss. A conductor is an ordinary material like a metal. If you try to run current through it, it flows very easily. Not perfectly easily. There's some collisions between the atoms and the electrons. Energy is lost into vibration, which becomes heat. Then a semiconductor, there's about 8 elements diagonally in the periodic table that are semiconductors. They will allow electric current to flow through, but with difficulty and depending on circumstances, which is exactly what you want if you want to build a computer, because you want something that conducts and then doesn't conduct and then conducts and then doesn't. 1, 0, 1, 0. That's why computer chips are made out of silicon and germanium. An insulator is a material like paper, glass, plastic, air. They don't let electric charge flow through them at all. Now you can put electric charge onto the object, but it's just going to sit there on the surface. It's not going to travel through. A dielectric is a special kind of insulator. Usually the electrons are sort of randomly scattered around their nuclei, but if you say put a big positive charge over here, it's going to like pull on the electrons. They can't travel, it's an insulator, but they can sort of lean to one side, and that's enough to make sort of a bias. And this is actually very useful for amplifying the strength of a capacitor. So that's the other kind of material you need to know about.